Now you are on part 6 in this lesson. It's area of a triangle. Now we know that the area of a triangle is base times height over 2. But if I don't have the height, how can I find the area of a triangle? If I want to take here, for example, this base and this height. So I have my base is b times the height h over 2. Now I can calculate h in two different right triangles, or in BHC or in BHA. If I took it in BHC, I will take sine opposite over hypotenuse. So h gonna be a sine c, and if I take it here, h gonna be c sine a. So I can have two formulas for the area of the triangle. So if I can, you can take any two sides, for example, b times c times what is the angle between a, for example, sine a over 2. Or you can take, for example, area is b times a sine c over 2. Or there is the third one, the last two sides and the last angle, it's a times c sine b over 2. So I have, guys, a three. Sorry, I didn't write the angle. So I have three formulas for the area in a triangle. Now let's start some application. And still in those exercises, we're gonna use the law of sine, law of cosine, the ambiguous case of the sine, everything. Find the area of the quadrilateral PQR as shown in the diagram below. If I look at this quadrilateral, this one is formed by two triangles. So to find the area of this quadrilateral, I need to find the area of the triangle PQR and then add it to the area of the triangle PRS. Excellent. Can I find directly the area of the triangle PQR? You need to look for two sides, and an angle should be given between those two sides. Two given angles between them a given side. Two given sides between them a given angle. I have it. So what is the area of the triangle PQR? It's 10 times 13 times sine 125 over 2, and I have the area and the unit squared. Now, the area of the second triangle, PRS, I have this side, this angle. Which side is still missing? PR. So it's PR times SR times sine 70 over 2. How are we going to find PR? I can find PR. Can I find it in this triangle PRS? No, it's not enough because just two informations are given. Can I find on the other triangle? Yes, three informations are given. So, and I have an angle between two sides. So I'm going to use the law of sine to find PR. So I will use the law of sine, and I will have PR squared is equal PQ squared, law of cosine, sorry guys. PR squared is equal PQ squared plus QR squared minus 2 PQQR cosine 125. Now I'm doing the revision for law of cosine. And then I will get the side PR. Once I have it, I can find the area. It's equal PR times SR times sine 70 over 2. And then to find the area of the figure, what should I do? I will add the two areas and I will get the area of the quadrilateral. Exercise 2. Find the difference. That's it. This one, we are back to the preceding lesson, the ambiguous rule of the sine, and let's see. Find the difference between the areas of two possible triangles. ABC, in which I have an angle given and two sides. But if you notice here, the angle that is given is not between the given two sides. So I'm in the ambiguous case of the sine rule. So it means if I want to draw this triangle, guys, if I want to draw it, again, I will put AC 104. You will make the angle 20, and this side here, I don't know its length, but I know that C is here, and I need to do the side CB equal to 52. So you take your compass here and you're gonna draw a circle like this of radius 52, and you see that the circle will cut this side in 2 points. So I have two B's, and those two B's are supplementary. So I will first work with the triangle ACB, as I said. Once I find B, I can calculate the other way by doing 180 minus, and I will have two triangles, and I will have two areas. So let's do the first triangle, triangle 1. So I have, to find the area, I need the angle CY, because to find the area, we need two sides, and between the two sides, the angle should be given. Those two sides that are given, so I need this angle. To find C, I need to find first B, and once I find B, I find C. So I need to find So if I want to, first I wrote here the formula. So it's 104 times 52 times sine C over 2. But to find C, I need to find B first. So law of sine. Law of sine gives me sine B over 104 is equal sine 20 over 52. I got B 43. How are we going to find the angle C? It's 180 minus 43 minus 1 minus 20, 117. And now I can replace it here to find the area of the first triangle. Now, triangle 2, the angle B now, the other angle B gonna be 180 minus this angle B that I got here. So it's gonna be 180 minus 43. And then I have another triangle. I have 20, 137. Now it's easy. How can I find C? It's 180 minus 20 minus 137. It's 23. How do we find the area of the second triangle? Two sides should be given and an angle in between. So it's 104 times 52 times sine C over 2. I got the second area. How do we find the difference between the areas? We subtract and we find the difference between those two areas. Exercise 3. The diagram below shows two chords. I have XY and YZ. And I have a circle of center O. The radius is 5. I have 3 here and 7. Find the area of the quadrilateral. Again, to find the area of the quadrilateral, I will cut it into triangles. So I need to find the area of the triangle YOZ plus YOX. If you see here, we don't have any angle, but we have many sides given. So, for example, I can find this angle here to find the area using those two sides and this angle. I can find this angle, either this one, any angle that I will find, but I decide to find in the first triangle YOZ and the second triangle XOY. And since three informations are given to find the angle, so I need to use the law of cosine. So I took in the triangle YOZ, YZ squared is equal OY squared plus OZ squared minus 2 this times this cosine YOZ. We solve it to replace. You find the first angle, this one is 88.85. To find the other angle and the other triangle, I will have xy squared is equal to xo squared plus oy squared minus 2 ox times oy times cosine xoy. I got the second angle. And now I can find the area of the first triangle by using the formula side times the sine of the angle between the two sides. And then once you have the two areas, you add it and you have the area of the figure. Guys, I'm going fast because it's easy. It's simple. It's not hard. It's just you are doing a direct application for the formula. When it's complicated, I will take my time to explain it. This figure, I draw it again because it's a 3D. You need to see it from up because AB it's standing. So this one it's as it was like this, it's like this, and this one it's standing and joining those like this. So it's a 3D figure. That's why I draw it again to see it, guys, as it's a 3D figure. And if you see here this in this figure, I have the faces DAB, it's a right triangle here, CAB is a right triangle, and all the objective of this exercise, I need to find the angle CAD. To be able to find the angle CAD, I need to use the law of cosine. The law of cosine, it means I need what's still missing. Still missing. CA is still missing and DA is still missing to be able to do it. So to be able to use CD squared is equal CA squared plus DA squared minus 2 this times as cosine. So I need those two sides. And to be able to find those two sides, each one I will find in a different angle. So let's start to find first the sides AD and AC. AD I will find in the triangle DAB. DAB is a right triangle, and we know that to find sides, I can either use Pythagoras or the trigonometric formulas. I have an angle and I have an opposite side. Which side it's missing? The adjacent. Opposite and adjacent, I'll use tangent. So tangent 55 is equal opposite over adjacent, and then I will cross multiply and I will find AD is equal 8.4 centimeters. Same thing, to find the side AC, also at the right triangle, tangent opposite over adjacent, and you will have CA is 7 centimeters. Now I have three sides. Can I find the angle? Yes, I can find it using the law of cosine. DC squared is equal to CA squared plus DA squared minus 2 CADA cosine CAD. And then I solve to find the angle, and the angle is approximately 153 degrees. Now we move to the last exercise. This one will take a little bit more time. Now here, first we need to fix the given. I will tell you what to fix in the given. It's not clear at all. And the diagram below O is the center of a circle with radius r. So the radius is not given. So everything that we're gonna calculate it here is gonna be in terms of r. I have the angles, those are pi over 4 and this is pi over 6. First question is find the area of the triangle POQ. So we know the area is, it's easy. I need to have two sides and the angle between the two sides. The sides are given. It's r times sine, it's 45. Pi over 4 is 45 plus 30 plus 45 is 120 over 2. And then the area it's in terms of r. It's r squared radical 3 over 4. Now part B, please fix the question. Find the area. We don't have something called minor segment. Find the area of the find the area bounded by the circle. So I have the circle and the chord PQ. So this is PQ and this is my circle. So I need to find this part here. Did you see it? This one. To be able to find this part here, I need to find the area of all the sector here, the green one. Did you see it? Minus the triangle, this one will remain. So the minor sector, this one, we have the formula. It's half r squared theta. So it's half r squared and theta, the angle, it's pi over 4 plus pi over 6 pi over 4. Oh my God, I wrote 4 pi over 2. I'm sorry, guys. Pi over 4 plus pi over 6 plus pi over 4. And then minus r squared radical 3 over 4. It's the area of the triangle that I got here. The calculation is right, but I wrote here pi over 2. And then here, when I do the same denominator and I do the calculation, I will have it pi r squared over 3 minus r squared radical 3 over 4. Question C, the same thing. Find the area bounded by the circle and the chord RS. So this is my circle, the chord. So this, I need this small part here. So to be able to find it, we need to find the area of all the sector, guys, minus the triangle. So the sector also is half r squared theta. So it's half r squared times pi over 6 minus the area of the triangle. It's easy how to find it. It's side times the sine of the angle over 2. And then I got the area of this part. For the last question, show that the shaded area is equal to this one. So if I go to the shaded area, guys, and I want to look at it, this shaded area, it's all this part that I got it in part B minus this small part that I got in part C. In part B, we got this part without the small part here. So in part B, we got all this purple here. Did you see it? The one that in purple, let me make it. So in part B, we got all this purple one. And in part C, we got this red one. If I do those minus, I will get the shaded one that they need. So I got the area I just replaced. Pi r squared over 2 minus r squared, that's 3 over 4. Minus, we need to be careful. It's minus this one. So it's minus pi r squared over 12 plus r squared over 4. And then here, I will not need to add those two together. I have same denominator, 4 pi r squared over 12 minus pi r squared over 12 gives me 3 pi r squared over 12. When we simplify, divide by 3, I will have pi r squared over 4. And what's still remaining? Minus r squared radical 3 over 4 plus r squared over 4. Now, if you factorize by r squared over 4, you will have here pi minus radical 3 plus 1, and I have it proved. That's it for this video. See you guys in the next video. It's part 7 and it's also easy, it's not complicated.